Okay, so we're going to talk about the 30, 60, 90 triangles, and we might remember our ratios that the shorter leg, if that's s, then the hypotenuse is twice that, and the longer leg is s root 3, but a lot of times we do it so often we forget why that works, and so we're going to go over the reasoning of why those ratios work and why we can use them. So to start, we're actually going to start with an equilateral triangle. And we know if it's an equilateral triangle, then all the angles are 60 degrees, equal angular as well. All the sides are congruent. And then we're going to split this. I'm going to draw in the altitude. So I can draw in an altitude. All triangles have altitude, no problems. And when I do that, I create two congruent triangles. I know they're congruent by my hypotenuse leg theorem. I have a theorem that says if I have two right triangles and I know their hypotenuses are congruent and their legs are congruent, then the triangles must be congruent. So because these two triangles are congruent, I know all their pieces are congruent. Corresponding parts of congruent triangles are congruent, CPCTC. So I know that these pieces are congruent. I mean, it looked like it split it in half, but we don't really know until we prove it. So now I know for sure that these angles are the same. So this must be a 30-degree angle, and that must be a 30-degree angle. So there's our 30, 60, 90 triangle. Now if I decide to label, remember all these sides were equal, if I decide to label this 2s, 2s, and 2s, then I know that I could label this part just an s, because for the same reasoning, I know that this piece and this piece are congruent because the CPCTC again. So this is s and that is s, nice and equal. So yay, we have the s, we have a 2s, and that length there we don't know, but we could call it x, and we could solve for it using Pythagorean theorem because we have a right triangle. So I can say that x squared plus s squared equals 2s squared, a squared plus b squared equals c squared. So x squared plus 2s squared equals 4s squared. Now it's just algebra. X squared equals 3s squared, subtracting this s squared from both sides. Taking the square root of both sides. Normally I'd have a plus minus, but it's a real life figure, so no negative lengths for us. And just simplifying that radical, the s squared, square root of s squared is s, that pops out, the root 3 stays in, and so that x must have been s root 3. So now we have it. We have proven that if that length is s, then the other leg, the one across from the 60, is s root 3, and the hypotenuse is 2s. So that ratio stands for all 30, 60, 90 triangles.